So my name is Oren Eini. I'm also known as Andrayan. I have a small blog that I like to write in. And I have about an hour and a half to discuss a topic that is very near and dear to my heart, stupidity. And mostly it's about, okay, for a long time I was a consultant. I would come to company, I would tell them, you're doing things wrong, this is how you should do things. And that worked very well. Unfortunately, I kept seeing the exact same mistakes over and over and over again. And eventually it felt bad, so my company started actually creating tools to work on that. If you read my blog, I had a series of blog posts documenting different bad practices that I see over and over. And this is basically what we're going to discuss today. This is a puppy. This is what your application to look like. This is what you do to your application. And this is the actual title of this talk. While building three-layer application, repository-laden, abstraction-heavy application is like drowning puppies. And let's talk about history. Does anyone know what this is? Sorry? This is a hard drive. This is a 1979 hard drive from IBM. Anyone wants to guess how much data can fit on this thing? Sorry? The actual number is 250 megabytes. It cost about as much as this building. Let's skip a few years ahead. We have this guy. This is 10 megabytes. This is the price. Oh, by the way, you see this asterisk? This is because this is used. A new hard drive would cost you something like $5,000. Now, $5,000 for 10 megabytes is a lot of money, right? Anyone here is willing to pay $5,000 for 10 megabytes? 10 gigabytes? 10 terabytes? Okay, you do realize that they jump 1,000 every single time. So here's an interesting aspect to that. This is not $5,000. This is $5,000 30 years ago. Okay? So we're actually talking about something more closer to $15,000. Just to give you some idea about what numbers we're talking about. So, at that time, what sort of application did we build? They had 1 user, 2 users. It was always on the same machine. If you had, at the time, you also had multi-user systems. But that was basically what we would today call a web application. You would connect using a green screen client, and it would basically send you a list of, right now we call it HTML, then it was basically commands where to draw things on the screen, and it would basically send commands back to the server. This is what they did, what now? So that was the applications that we used to build 30 years ago. What happened? Yes, time passed, like right now. What happened from this point? Someone please raise their hand and answer. If someone will not raise their hand and answer, I will randomly select a victim and make him answer. Okay? Yes. I wasn't joking. You. Yes. What happened since that time?
Connected apps, internet.
Okay, connected app. Wait, you're going way too fast. Okay? We are still taking that in very small increments. So the next step is actually the network. And this is when you actually, if you worked in a big business, they actually have a network, and they had this thing where you can actually send data from one machine to another without using floppies. And that was amazing. And that is when we actually started to have the architecture that today we call it client server. So this architecture is one application. There is no notion of different machines because there wasn't any different machines. And then we have this with the client servers, many clients. Do you see this asterisk? What was the server at the time? This is just around the time where the relational database won the database wars. What was the server at the time? Sometimes, but most often, you couldn't afford the mainframe. I'm talking not about the headquarters. I'm talking about the regional office. At that point, you generally bought a mini computer. Just to give you some idea, mini computer, this is considered in that terminology to be microcomputer. A mini computer would cost you about as much as $100,000. Again, those dollars. And it would be appropriate for you to run something on, but you still had the mainframe that it would also talk to. But then you also got a bunch of PCs which were very inexpensive, $5,000 to $7,000 each, and then you connected them. And on that mini computer, you used to run a server. That server usually was some sort of Oracle, Sybase, one of those things. The server in this case would be a database server. And what sort of client would we have? Typically, it would be a client that would do actual operations, actually send SQL commands directly to the database server. This is how we achieved applications, multi-user application. One thing to note here, however, low number of users. This is important because what was the next step along the way? Sorry? Many users. Okay, so this is the server. And here are a few problems before we go there. So the first problem is the clients actually have direct access to the database. And that might be a problem if you actually care about small things like data integrity. And given that you usually did payroll on those systems, I really like the ability that I could just open up a console window and start typing in commands such as my salary times 2, update. And what was the solution to that? Anyone? The solution for just anyone can write any SQL that they want against the database. Sorry? So you say add another tier, that's too expensive, you can't do that. The one tier, $100,000. So what did we do? We went to the database vendor and told him, look, we're using your database as a server, but we need access control. Give us access control. And we need a way to provide named operations. So you couldn't just do anything that you want, but you could do the thing that we want you to do. Such as, for example, create a new order and not just increase your paycheck by 10 times. So that is when we created APIs, store procedures. And the server is still the database. The API is store procedures, and then we have security on that. How many people still use that model? Really? Okay. Few over here. Think you? No? Okay. So just a few over here. And this has been, by the way, right now, just to give you some idea, I'm taking you through a tour of time. In just a few slides, we move about 10 to 15 years. And this was what people did because this is how you develop software. And right now we are in the early 90s. And this is how it looks like. At the time, by the way, we started to have Windows. We started to have we started to have Visual Basic. Most of the applications are actually Visual Basic applications. Talking to Stored Procedure API, sitting on some database. And that was how you develop software. The next step was the web. And here is a very important thing that you have to remember. People really, really don't like change. If someone goes to work every day using the same route, and you put a roadblock in the middle, what will they do? Sorry? They can drive across it, or they will do the same thing and just do the smallest possible thing to continue doing what they've been doing before. This type of behavior, is it familiar to you in any way? We have the web. We have many users. How do we solve this problem? Oh, and here's another thing. At this time, a server costs something like 10 grand, $10,000. That is affordable. So how do we solve this problem? One interesting thing, the databases literally could not function with too many users sitting on top of them, because they were never designed for that. The web was very new. So you had databases that were intended to be used by 10, 50, 100 users. And suddenly we're talking about thousands of users. So what did we do as an industry? Sorry? So now we moved to a slightly different technology. We introduced the business tier, as it was called. Okay? And what happened in the business tier? What was the most important function of the business tier? Give me options. Sorry? Yes, but why was it so important? Sorry? Scalability, yeah? Okay. Exactly. The transition from many users to one user. Do you know what made this a success? One very, very small and stupid thing that has hugely important implications. Connection pooling. On this guy, we had connection pooling. So yeah, we had lots of clients here, but the database server only saw decimal of that, tenth of that, 1% of that maybe. And by just dropping this server in, we got everything that we wanted. We still had the same model. We have stored procedures talking to a database, and now we have actual server. All of the clients talk to this. How many of you work in this model right now? Yeah. So much fun. Okay? It's all about connection pooling. Afterward, people needed to justify that. So no, this is where you put your business logic. It's for security. Do you know that there is a guy, usually looks like this. He sits in meeting like this, and he gets to make pronouncements. No, we're not going to do that. That isn't how we do things. We've always done it this way. You know the guy, right? Yeah, I can see that you do. And guys, here is this architecture. Where are we on the timeline? Can you guess? Sorry? 99, 2000, exactly. Here is the databases, here is business logic, here is the actual presentation stuff. This is about connection pooling because this one can't handle lots of users. That's about it. So, now, today, how do we do it? We don't actually do a lot of three-tier system anymore. Usually we don't need to. Either we have two-tier, web and database, or we have total scale, which means web farms, database farms, those sort of things. In many cases, actually preferred to take the whole system, which may be complex and big, and break it apart into something much, much smaller. Into a system that can be actually just two-tier, web and DB. So why am I talking about all of this? Anyone wants to give me a guess? This is all ancient history. 40, 30, 20, 10 years ago. How is this relevant? Sorry? I'm sorry, I literally cannot hear you. It illustrates change, okay. What's more? This is why we are actually doing things. Right now, this is how, if you go and open most architecture books, you will find something like this in there. And they will do a write-up, this long, about all of the benefits and all of the advantages and why this is the only thing that you are ever going to need. And in the end, the reason we got there was because of connection pooling. If these guys have been able to do it better, we wouldn't have needed all of these things. And we would probably ended up with some totally different default architecture. So here is an interesting thing. The interesting thing about it is that what I described so far was mostly hardware, physical deployment. We don't do a lot of that anymore. What I'm going to actually talk to you about today is logical organization, how you actually build systems. Not in terms of how you deploy them and what server it goes on, but how you actually build the actual system, the actual source code. And hopefully, we can learn from that. So, a long time ago, again, we had direct database access. And then we had store procedures. We got there because we didn't want to expose the actual database to the client that were actually on the same network as us. Now, what's the difference between being able to do direct SQL calls against the database and being able to use store procedures? Anyone know what the difference is? If I have the ability to call a store procedure, or I have the ability to execute some random SQL, is it meaningful from the point of view of the system architecture? Anyone? So direct data access means that it's one layer less. The most important thing is that if you have to work with store procedures, you usually only have store procedures. And they tend to be very procedural. It's in the name. And if they're very procedural, you cannot just compose them and work with them in any way that you want. If I want to get the order joined to the order lines, if I have direct access to the database, I can do it like that. If I don't, well, I need to write a new store procedure. Maybe I don't have access to that. But I have get order lines IDs, and then I have get order line. So I'm going to do a select n+1, because that's the only interface that I have to the database. Because of security, because the move to store procedures actually severely limited what we can do with our software. We wanted that limitation, because anyone could just walk into the lab and says, hi, I want to change my salary. So we introduced store procedures. But today, so this is how it looks like. I especially like this thing. This is order by name, this is order by latest. Do you remember those? When you have find customers, 60 different options? Slightly different. Do you remember when they told you that, oh, store procedures are great, it isolates you from changes in the database? And then you realize that, oh, I need to change something in the database, I have to update 61 different store procedures. And just for fun, you also had to find some way to do that in a way that was actually versioned along with your software, because you didn't have enough problems in the world. So we move on. So again, we went back several years, several decades actually, and we move on. We are now back again at relatively modern history. And now we have this guy. What is this guy? This is how you're supposed to write software. You have customer controller, and I'm just going to stop at the MVC controller or the ASP.NET code behind, just so we won't get into the complexity of doing UI. But you have the controller, and the controller goes through a service. And the service goes through a repository. And then I run out of the ability to do those things, so you have an ORM and a database behind the scene. Notice what is the importance that we put to ORM and database. They are way, way over there. We don't want to see them. And here's the question. Do you want to see the result of this in action? Where we have taken this? It's this guy. Now, I know you can't actually see things. So let's see if I can increase the size. Can you read it now? Now, I took this from an application that is meant to be best practice for developing domain-driven design applications. Allow me to check. Create topic, delete forum access restriction, delete forum translation. Get all access forum restriction, get all forum, get all transaction, what? And I really like all of these parameters. Look at get all forums. Does it ring any bells? No? What if I put a US pin before of that? Let's see if I have other interesting things here. Dear God, look at get all ranks, get all posts. Anyway, so this is what we ended up with. And let's see if we can look at the actual code that this uses. So we have update forum. This is the controller. You can see we are good. We use IOC. We can be testable. And we get the forum service. And then we call update forum. Question. Can you tell me what this code is doing? Absolutely nothing of value. This code is not doing actually anything valuable. Let's go deeper. This is where we get to the business logic. Do you know how I know it's business logic? I know it's business logic because the project was called business logic. And let's see what it does. Note, we have providers. I can go and look at at my patterns book. I have the provider pattern. I'm good. Because I have a pattern and I have a book that says this is good. So let's see again. What am I doing in here? Anyone wants to guess? Actually, you shouldn't guess. You should know. Okay, wait a second. What is the important business logic? So you had something? Yes. Yeah. None of which is business logic. All of this is infrastructure code. Caching is infrastructure. This guy, this is infrastructure. Post entity update. Just to give you some idea, do you remember this one? They had method like this for each and every one of those. And you see this is iForum API. They had iSomething API, and they had a lot of them. iUsers API, iTables API, iChairs API. So this isn't actually doing anything useful. But wait, let's go down a bit, okay? Let's go here. What just happened? Anyone wants to give me a guess? I thought that we move in time. You have to understand, when I actually got there, I sat down and cried a bit. Just to give you some, this sort of code I have to write when I'm working against unmanaged databases that were written in the 80s. You don't write this sort of code anymore. You don't need to. Anyone here thinks this is the way that you should write software? Anyone? Why? Okay. I'm sorry, if you can't justify that, I'm not going to count your opinion. Okay. I actually think that what you probably mean is that this is how we always done software. This is the way to do. Why? Because this is the way to do it. We have always done it this way, therefore we will always do it this way. But you know what? I'm pretty sure that at least some of you thinks, he's talking nonsense. I use modern software practices. Oh my God. So let's look at modern software practices. This is taken from another application, and this is just to give you a demonstration about what it takes to actually do something in the application. So let's follow what's going on. We start from the catalog controller. We call this worker service. We call the catalog service. We call, I actually, by the way, in here I had to remove some things. So we call this facade. Do you want to guess what this facade return? And then we return some values, return them again, we call again. All of these things happen, and then we finally return. Just look at the shape of that. Now, this is all proper and nice and encapsulated. This also tends to happen to be a really, really bad performance problem. Because in here, based on this value, we read in a loop. So this is actually executed n times. Let's continue. And the problem is that this is really, really common. Not because people are stupid or bad, but this is how we always done things. And you will allow me, I'm going to continue in this vein for a bit. Sorry. Now, I intentionally chose some drastic examples. But how many of you know software that looks like this? Whoa! Okay, for the record, everyone raised their hands. And how many of you work with software that looks like this? Yeah, right? Anyone here had to go more than 5 layers deep from something happening in the UI to something happening in the database? And how many times this is just A calling to B, calling to C, calling to D, calling to E, and absolutely no value added whatsoever? Yes, as I said. So, it's not maintainable. You have tons and tons of code that is just there sitting. And it doesn't do anything. It adds no value. But it has to be maintained, debugged, and just nonsense. Okay? So, this is the problem. The problem is that this is the architecture that people tell me is the best practice. And I come to them and says, look, I read the books. I did my homework. Here is the Microsoft article, not from 6 years ago, from last month. It says, do this. This is how you do things. So, let's move from the realm of old software. Let's talk about the new stuff. Okay? So we have this lovely, lovely architecture. Can you see my architecture? I have repository manager. Every time you see repository and a manager, please run away. Either one of them is the reason to run away. Both of them together just run. So now you can see that you have lots of implementation for the repository. This is if you're old school, ADO.NET. Link to SQL and Hibernate, Entity Framework, mock repository, blah, blah, blah. Not going to work in practice, but this is a good lie. This is the best lie because it keeps you hoping that in the end you will go through the gate and everything will be nice and happy. And it just doesn't work. Even if we talk just about Entity Framework and Hibernate, they are drastic and they are both drastic changes between an Hibernate and Entity Framework, but that is it is good. They are drastic, they are well known. But there are also subtle changes between an Hibernate and Entity Framework. For example, how many of you use Entity Framework? When you create a new object in Entity Framework, can you tell me at what point it's get allocated its database ID?
You mean when you save it?
When you save a new object to the database, at what point does it get the new ID?
It does save changes and it does a select on the identity.
In an Hibernate, it doesn't wait for you to call save changes. It does so immediately, and it does so immediately only based on whatever you're using an identity primary key, a GUID primary key, or a Hilo primary key. So if your ears just started bleeding from the terminal, just started shouting here, this is the sort of subtle changes that I'm talking about. And it turned out they are pretty important to know when you actually get the primary key of an entity, kind of important in our business. And when you have these subtle changes between things that are actually fairly common. So this thing, the iRepository, is doomed to fail. But still, okay. Now let's talk about something fun. This is part of a code that I stole from a blog post that talks about let's build the proper to-do application. We will build it with all of the right patterns and behaviors and everything to create a great application. It's a to-do application. How complex can it be? But let's take it, okay? So what do we have here? Anyone wants to comment on this? I can tell you just from looking at the interface, I want to cry. Here is why. Get tasks, which return an I list. What's the problem with this method? Paging. What happens if I have 100,000 tasks? Very often it feels like I have 100,000 tasks. So when I'm calling this method, I'm basically committing suicide because I'm going to have to load all of them into memory. So I don't like it even before we actually got to the implementation. But let's look at the implementation. Someone please explain to me what's going on. I have a service. What is this service doing? Sorry? Nothing of any interest. But that's okay, it's delegated to the repository. This is how you use it. This is where you kill yourself. By the way, notice that you can actually do that. You can just create new task service. Oh, you can because it does this, I'm sorry. Yeah. Anyway, guys, I haven't actually looked for bad code examples. Do you know how I found all of those? I searched for best practices. Honestly speaking, go to my blog, you will find most of them there. So, and then we have the iTask repository. And then we have the actual repository. What is this doing? We have a repository. Yay! Finally, I've found something of value. You know what the really sad part is? Even this isn't necessary. You can just do return DB tasks. It will do the same thing. So, I want to load a task from the database. In order to do that, I give the iTask service, and I'm going to call this method. In order to do that, I have to instantiate a task service and a task repository. Then I'm calling this. It called get tasks, which then goes to the DB context and get the tasks, wrap it in unnecessary iQueryable, and then call with ID, blah, blah, and call single. Wonderful. All it took is two interfaces, two classes. It's like your share, 2 + 2 = 5. For me to be able to do this. And you know what? at the end, I have accomplished something. I have faced adversity and wrote a lot of code to be able to show you a to-do item. The to-do item might be rewrite the application. It's too complex, but at least I was able to do that. Now, spot the differences. Just to give you some idea, I found this girl to be more honest. So let's see. Good. Oh. Yes, we aren't done yet. This is another best practice example. Now, oops. Tell me what you see in here. Guys, what do you see? Yes. Okay, but look at the actual code. Home controller worker services. This is someone who already identified that they have a problem. We know that we cannot, because this is probably the same guy from the iForum API with the thousands of methods. So now they decided, okay, I'm going to split up my application and I have to have the worker service for the home controller. So let's look at this. Remember, we have IOC. Remember, we have this wonderful link thingy. And still, I have to ask, why? Look at this guy, he's so cute. Why are you doing this to him? Okay. Yes, he's also cute. So far I've been talking and give you all sorts of ugly examples. What's the point? The point is mostly to get you to think about the sort of thing that you're doing now and why are you doing that. In many cases, what we are doing is what we've always done because we've always done it. And unless there is a good reason to change, we aren't going to do so. And you know what the really funny part is? It doesn't actually matter. It really doesn't matter how much, whatever the original reason for what you're doing, if the original reason for what you're doing is no longer relevant. We started out with the 3-tier architecture because we have the connection pooling problem. But right now, if you find the average architect, they won't even think about connection pooling. They will give you things about architectural stability and the ability to connect additional front ends and all sorts of other stuff like that. But that isn't the reason. It's just they found new reasons to do what they've always done, so they don't have to change anything. Okay, another common problem. This guy is a homeless dog. And this guy is wonderful in reusing things. What's the point? How often do you write reusable code? Anyone? You learn not to raise your hands? So the point here is that very often we get told that we should create reusable code. In university, in classes, when we start out as developers, reusability is good. Why? Why do we get told that reusability is good? Yeah. Save money? How? Sorry? How? You don't write the same thing twice. Okay. And what is the trap of reusability? Sorry? One problem is you ain't going to need it. So let's say that you ain't going to need it applies. What's the problem with that? What's the problem with being reusable when you're not actually usable? Well, sorry, what's the problem of being reusable when you aren't? Blah, 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 blah. Sorry, 1 second. Let me get my tongue under control. What's the problem in being reusable when you aren't being reused? You put an effort. There is actually a non-trivial cost in building reusable software. You have to design for all sorts of scenarios. You have to explicitly open reusable options. You have to design your software drastically different. You have to be prepared to get garbage input, or even input that is okay, but is, from the business level, it's meaningless. So, for example, if I build software to give out loans to people, and I have open loan file, this is something that I need to do. And I have the person's birthday, and I have the amount of loan that they ask. What sort of validation am I going to do there? If it's my own code that is going to do that, I'm going to do validation such as this is the loan amount is within the range that we provide. The age is not negative and it's not over 200 or something like that. This is standard stuff, right? Not really meaningful from a business perspective. Anyone here thinks that an 80-year-old can get $10,000 loan? But we don't validate that. And it's, from a business perspective, it's about as nonsensical, never mind, doesn't make any sense, in the same way as if I was trying to give a loan of $1 to a guy who is 300 years old. And still, that's one problem. What's another problem? So one problem is I'm reusable, but I'm not being reused. So I just spent a whole lot of effort and money to get something that I'm not going to use. So the problem with reuse, when you're actually being reused, you get into a whole bunch of trouble. For example, I need to show the customer details. I need to show them in two places in the application. One of them is in the customer card, when they go and look at his detail and maybe can edit them. The other option is in the admin screen. I'm being smart, I'm going to reuse things. I'm going to have only one place that says load customer details. Make sense so far? Yes? Good. So, what's the problem? It happens to be the case that when I'm talking about load the customer details for the purpose of the customer viewing them, and load the customer detail for the purpose of admin doing something, I actually mean two different things. Worse than that, I might only discover that after some time have gone by. And now I have a change that I need to do for one particular scenario that isn't applicable or even harmful in all other scenarios. Do you know what I do then? I add a Boolean. Eager fetching is a great example of that. Yeah, exactly. So I'm very, very careful about what I'm going to say that I'm going to reuse. Because reusing stuff has a cost. And I don't want to end up like this guy. Actually, he seemed very happy. So, after all of this fire and brimstone stuff, what do I actually suggest? How do we actually approach building software? You know what? Let's do a quick quiz. What did I say that I don't want to do? Yeah? Don't add too many layers or too many abstractions. Okay? What's more? Do not write unnecessary code. Those are platitudes. Those are just empty words. It's like saying, don't worry, be happy. It doesn't solve anything. It doesn't actually tell you what to do. Yes? No? So let's look at this. As you can see, this is a controller method. This particular controller method is part of Raccoon blog. This is the software that run my blog. Tell me what it does. Anyone? Give me the users. Give me the post. In this particular case, this is what is responsible for rendering the home page. So, give me the public post, order by descending with paging. That's it. Then sending it to the list view. And there is nothing else that needs to be done. How many layers of abstraction do I have here? One. How complex is it to understand the code? It isn't that complex. How complex is it to modify the code? But wait a second, what about all of those reusable pieces? I have logic that I may need to change in many places. How do I deal with that? Would I actually have to go and rewrite significant part of the application every time I make that change? Okay, so let's look at what's going on. In this case, I said this is the only piece that is actually have some sort of a business logic. In this case, what this says is that the publish date is in the past. It may change. Maybe I want to decide, no, I want a publish flag in addition to the publish date. This is abstracted into an extension method on the query. Everything else in this method is specific to this scenario. I don't need to try to create complex stuff. I actually have to work very hard to keep things this simple. Let's talk about, can you read the code, by the way? Is it big enough? Yes? Okay. So let's talk about something slightly more complex. Instead of just doing reads, it's very easy to say, okay, when you're doing reads, just do it this way. Just use the session directly, do the query, send it to the user. You know what, let's talk about this for a second. What's the major advantage that I get when I have an architecture like this? Where when I'm doing a read, it just open the session and do something. Anyone? A really important advantage. You know what? Let's compare this to the alternative. What is the alternative for this type of code? Service, service, repository, DAL, ORM. Sometimes it's even more than that. Like several times I've seen people that sticks WCF in the middle, apparently because they're masochists. So, if I wanted to do this using the service repository model, how would I do that? The amount of code wouldn't change that much. It would maybe triple from 5 lines of code to 20 lines of code. So that doesn't worry me much. But what does worry me about this? Sorry? Too many translation. What happens when I need to make a change? I have created a wonderful architecture. I have interfaces all over the place. I have services to isolate behavior. I have repository to isolate the database. I'm ready to make a change, right? How hard is it going to be to make a change in the repository application? Is it going to be easy or not? Anyone wants to take that? Give me an answer. On what? No, this is actually a great answer. On what? On what? So I can't hear you. Thank you. Thank you. As it turns out, in the repository in service model, there is actually a set of changes that are extremely easy to do. For example, I want to replace the repository implementation with another repository implementation. I have explicitly set it out so that sort of change is very easy. I just replace the implementation in the container, in the IRC container. As it turns out, this is not really useful. Why? Sorry? Maybe you ain't going to need it, but even if you try, what are you going to find out? What you're actually going to find out is that you haven't specified what your repository implementation is going to be. You can change that, but you have specified what the repository behavior is going to do. And it's going to be very hard and very expensive to do that. How many of you right now use entity framework behind the scenes, behind the repository? Do you have a method called attach? Save changes on the repository interface. Okay. When you use, how many of you use and Hibernate behind the repository? Do you expose method like commit or evict or merge, refresh? No. Do you store? Do you expose save or update? No. On what? Okay. Okay. Most of the time, when I go and look at customer code, I can see from the interface of the repository what data access they are going to use. In many cases, in repository that comes from an Hibernate, you will see methods such as save or update. Save or update is something that is only relevant for an Hibernate. If you have an Hibernate repository that exports save or update, and you now want to move to Entity Framework, it doesn't have a save or update. In fact, you're actually going to have to implement an Hibernate behavior on top of Entity Framework just so your software could work. That's what I meant when I said you can replace the implementation, but you cannot replace the behavior. And in some cases, that behavior is embedded very, very deeply into your application. Here, let's talk about another thing. I actually have now a send email service. So I abstracted it out and send email service. And what it turns out to be that sending email is very expensive. It's going to take a lot of time. So I want to change the behavior of the send email service from doing that in a synchronous fashion to an async fashion. But then you realize that you can't actually do that because you have other pieces in the code that depend on whatever the email sending have been successfully completed or not. So something that seems to be very trivial, let's change the email send from synchronous to asynchronous process, now become a major refactoring move because now you need to change the way that you actually handle behavior. Okay, so this is my rant about people who write a lot of interfaces and try to say that the system is amenable to change. The more interfaces and connection that you have in the system, the tighter it has become the tighter the system is hooked together. And any sort of meaningful change in the system is going to be much, much harder. How many of you here have tests? Test projects? Okay. How many of you do big refactoring? Okay, so you raise your hand for both test and refactoring. When you do big refactoring, did it ever happen to you that because that you had to unload or remove the test project temporarily? Okay. In some cases, if you need to change method or remove or add some, usually it happens for performance reasons. So you go out with the system and you find, oh, I have a performance problem, now I need to change something. And you change not the method implementation, but the method themselves. And now your test won't even compile. And the only solution is, wait, I cannot fix the test all the time. I need to actually finish what I'm doing and then I'm going to restore the tests. The testers aren't there to help you. They are actually there to chain you to the same spot because they're testing their own team. This is how I recommend doing writes. So this is reads, this is writes. Look at the code for a moment and tell me what you see. What is the depth of this code? This is an action method. This is on the controller. What is the depth of this code? Anyone? I need an integer number. 2. This is the controller, this is the command. Now, I want you to notice something very interesting. How do I execute a command? Sorry? I'm calling execute command. But look at this, for example. We have session here. How do we get this session? From where? I got it from the infrastructure. Look, I'm creating a new cargo, register cargo command in here. Presumably here I have some logic. And now you can see that I execute the command. By executing the command, stuff like the session got filled up. And this is actually very, very interesting because I don't have to worry about dependencies. It actually is more than that. In this system, I don't even have anything resembling an IOC container. I have 2, maybe 3 dependencies, and they are well known. This is the session, and maybe there is the session, maybe the event, the bus, and that's about it. If I need to do something else, I do it using a command, using a task, one of those things. So already I have reduced the abstraction that I have available and also reduced the complexity. In this code, I make assumptions. I assume that when you call execute, I will have a session. I assume that I have a context set up to me. By making that assumption, I remove a lot of the burden right there into the infrastructure. It's maybe 100 lines of code to manage all of that. But then this is what my code looks like. By the way, everyone here said 2. 2 layers of abstractions. It's actually 3. You see that we also have a query? So the basic idea, in most apps, I have 4, 8, maybe 10 major abstractions. And all of those abstractions follow pretty much the same rules. From here, from the register cargo command, I can execute other commands using the exact same method. I have an execute commander. And by making sure that everything looks the same, everything follows the same abstractions, I end up with an architecture that looks drastically different than the service repository model. Just to give you some ideas, controllers and views, you already know what they are. They are the same thing from MVC, for example. Entity, same thing. What's the difference between a command and a task? Yes. So a command is something that happens immediately. Task is something that happens in an asynchronous manner. Recently I started to call task jobs because in C# 4 and C# 5 we have the system threading tasks, so that's confusing. Now, no, I cannot. Here's the deal. When I have a task, when I have a job that I want to execute, so given this API, how do you think I will execute a job, execute a task? Sorry? I have no result value, okay. How will I do it in here? How do I execute a command? Guys, it's right there. How do I execute a command? Sorry? I call the execute method. I have a method called execute command, and that's it. I execute the command. Following the principle of least surprise, how would I execute a job, a task? Yes? So I can't hear you. You're talking about infrastructure concerns. As business level code, how do I execute a task? Execute task. Guys, all of you try to give me implementation details. I don't want implementation details. I want execute task. Maybe I will call it schedule job. But with just a method. That method promised one thing. At some point in the future, this will run. I actually had a TechPub video in which me and Rob build some sort of order processing system. And we went, using this type of architecture, we went from tasks that were executed asynchronously by the system using a background thread to tasks that were persisted to a database, loaded by a worker role who then execute them on a totally different computer. So the important thing here, remember what you're promising and try to promise as little as possible. In scheduled job, I don't want to promise anything except that the job would be scheduled. Then we have events and queries and blah, blah. Okay, let's talk for a second about the infrastructure. The whole idea is that we have limited amount of infrastructure. As a rule, developers tend to really, really like writing lots and lots of infrastructure. You know why? We have to write a lot of business code or business rules. And I intentionally do not use the term business logic because it's never logical. So writing tech stuff, infrastructure stuff, is so much fun because we understand everything. And I don't want to do that in my applications. I want to have very, very limited infrastructure. In most applications, I have something like less than 1,000 lines of code for infrastructure. And most of that is basically managing things like the session, like executing other commands, executing scheduling tasks, those sort of things. And the most important thing is that using this approach, I make a lot of assumptions. When I get called, I will have the session. And when being able to make that assumptions means that I can write code like this. And this code tends to be extremely business focused. But even something like this assumes that we actually have here some sort of a reusable query. I already told you what I think about reusable queries. Okay. In many cases, we have been taught that we shouldn't make assumptions, that we should inject everything into the system. This is a bad idea. Having to inject stuff to the system means that the system as a whole, not this particular piece of code. This particular piece of code may be simpler, but the system as a whole is more complicated. And you always have to remember that eventually, what you deliver isn't a single class. What you deliver is the entire system. Okay, let's talk about testing for a second. You know this image? This is usually how people talk about testing. This is usually how I think about testing. I already told you why. When you try to do unit tests, you tie down your hands. It's very hard for you to make meaningful changes. My last two big projects were RavenDB and the Uber Profiler, then Hibernate Identity Framework Profiler. And in both of them, most of our tests are actually system tests. The tests that spin up the system with key components removed. This is why it's so important to have good infrastructure. Because if in some cases if in production I want you to go to disk and save that and make sure that it's actually saved and flashed and everything, in tests I can say, okay, just write it to memory, we don't care. But this is done at a very low level of the system. So I still get very fast tests, but I actually test the entire system. And I get to do it something very, very much like this. This is my system. I get to do something here, test something here. In the middle, this is all black box. This is what I want. By the way, in many cases, I actually have to go explicitly into the system and add test hooks. So when I do something here, I can verify that it actually happened the way that I want it to happen. But that's okay, because the test hook I can live with. Having the test dictate to me for all time how my software should behave based on very early understanding of my software is unacceptable. Because this is what we're doing most times. We sit down very early in the game and start writing the tests. And you write a test, write a simple implementation. And write a test, another simple implementation. But very quickly after that, you start realizing, wait, that early understanding isn't correct. I need to change that. And now you have a breaking test. And that breaking test isn't meaningful. Okay, we just talk about it. Here's a good example, assumptions. You will have a user service. That's what I thought I needed in the beginning. Then I decided, no, it's not meaningful. I want to remove that. This is an internal implementation decision. Why is the removal of a user service causes the green to go red? Causes the build to go red? Makes no sense. Okay? So here is an example of allowing unit testing. You see what I have here? Alternative execute command. You see how this works? If I want to test the register cargo command in my test, what am I going to do? I'm going to create a new instance of the register cargo command or the controller, whatever. I'm going to set these two, and by just doing that, I switch up the entire infrastructure. Now I can assert after the fact that executing this particular action caused the register cargo to be invoked. I actually took it a few steps further. I also have infrastructure for my tests. So in my test, I write a method execute action, and I give it the type name. It goes and executes the action, and it does all of this setup, setting this up for me and everything, because the tests are also code that I need to maintain. So I hide a lot of that, again, in the test infrastructure. And I have the application infrastructure and the test infrastructure, and they talk to one another. But most of the time, the actual code, the actual test, the actual business logic, they don't know about this infrastructure, nor should they care. And here is the actual test. Here is setup query response for this thingy, execute the command, and the register cargo command is going to call the query, and we set up the result, and now we have the appropriate blah blah. So we end up with a lot of commands, a lot of queries, few queries actually, but a lot of commands, tasks, those sort of things, all of them look very much the same. If you have a lot of commands that look very much the same, what's the difference between them? The business logic. The part that you actually care about. Wait a second. What about things like logging? Like exception handling? Those are infrastructure. Those are cross-cutting concerns. I don't have to do complex things like AOP. Because I have the execute command, I can throw all of that in there. There is no one behind the curtain. Okay. So this is system tests. And okay, so in summary, we want to reduce the abstractions. We want to limit as much as possible the number of things that we have to remember. We want to go to the point where it's all cookie cutter code. Where most of the time that you're going to spend is just, okay, this is what I need to do. I'm going to write it down in code instead of in English or in German. Done. Next topic. And it's very, very easy to try to consider, there is this new pattern that I want to see. How many of you are currently working or want to work on CQRS application? CQRS? Anyone? 2? 3? Here's the problem. I got an email a few months back, and it told me, my next application is going to be a CQRS application. And I started to cry. You know why? This guy didn't know what his next application is going to be. He made a decision about the system architecture based on, I want to do CQRS, without regard to anything relating to what the system that he's actually going to build needs. This is what I mean by avoid the buzz.